My name is Ioannis Ntzoufras, and I'm the head of the Department of Statistics at Athens University of Economics. Today, I'm going to present a seminar talk on the scientific challenges and problems in football analytics. This is more like a review on the topic, not very technical, referring mainly to the problems that are very interesting in this field. First of all, I'm going to do some brief introduction to our group, back to Athens University of Economics and Business. The name of the group is AUEB Sports Analytics Group, and it is founded 5 years ago. It is a research group within the Computational Bayesian Statistics Lab in the Department of Statistics. The team leaders is myself, of course, and my good friend and collaborator, Professor Dimitris Karlis. And here you can also see the link of the group. The main events of the group are the workshops we organize annually. We have already four workshops, and this year's workshop will be performed on March or April. And we have also organized the Math Sport 2019 International Conference, the European Conference, on July 2019. And we have also organized a series of courses on sports economics by the well-known professor of Stéphane Quessin, and a short course on basketball data science by Marika Manisera. These are the posters of the previous event. As I said, we are planning to do a virtual workshop this year on March or on April 2021. We will announce details after the holidays. So this are some of the achievements of the groups. As we can see, one of the main contributions of the group is this analysis. Actually, this was long before the group, when with Professor Karlis, we were PhD students, and we were dealing with this topic as an academic hobby. And this publication has a lot of citations nowadays. It is considered as one of the milestone publications on the field. Here there are two more publications similar, that they are follow-ups of the first one. We are, as a group, we are members of the European Training Groups on Sports Analytics and Injury Preventions, and we have also some connections with the ETN on Real Analytics for Internet of Sports. Personally, I have been involved in 14 MSc theses on different topics. You can see here the topics, and one with collaborators in abroad, like my friend Niall Friel in UCD and Gianluca Baio in UCL. I have 2 active PhD students that are working on the field, and about 10 publications, some of them in really nice, in really top statistical journals, like the Journal of the Royal Statistical Society C and A. We are considering the possibility of having a sports analytics MSc in the future. Our publication on football modeling using the bivariate Poisson model is a key publication of the field. This is the one, as I already mentioned. We have many collaborations with groups and people. Here are some indicative names. Sotiris Drikos, the past manager of the Greek national volleyball team. He gives us a good feedback on data and the interpretation of the results on the field. Stéphane Quessin, who is a top sports economist, consultant of the Bosman case. Yannis Kosmidis in University of Warwick, Niall Friel in UCD, Kostas Pelechrinis in Pittsburgh, Gianluca Baio in UCL, Leonardo Echidi in Trieste, and Christos Marmarinos and Lazaros Papadopoulos via their website, which is called Newstat. We have also collaboration with the BD Sports in Brescia, and the Stichman was one of our main sponsors in our previous workshops and conferences. And lately we have contact with FSI, which is a fantasy sports interactive company, and one of my students started working there recently. So let's go now to our main talk. We're going to talk about analytics in football, soccer, and football is considered the best sport, not only because it's very popular everywhere except maybe the States, but also it's the best sport for implementing analytics or science in general or statistics. And the main reason for that is the low number of events. And the low number of events, they make it so difficult to predict what will happen. And this means that we have high uncertainty, so it is difficult to predict. It is very popular, maybe because it's very difficult to predict and people, they don't know the result before they see it. And it's very profitable because, again, the primary reason is the difficultiness in prediction. Although there are a lot of money on the field and people, they believe that the companies, the football companies, they earn a lot. There is a very high risk of investment for all professionals that they want to support football teams. And the main reason here is because the passion dominates the sports and becomes more important than numbers and science and money at the end point. So professional teams are usually acting as win maximizers. So their aim is to win and not to make profit. They are not profit maximizers, and this creates problems in the football teams as companies. So let's see the main topics here that we are going to deal. Some of them I'm going to give more details because I know them better and they seem more interesting for me. For others, I will just mention them. So first of all is prediction, and this is a field that we have done some progress. Player evaluation, performance analytics, one of the most interesting topics. Physical metrics of players in training, inline game metrics with wearables, scheduling, sports economics and competitive balance. Again, this is a topic that I like. And other like passing network analytics, referee effects, red card effect, home effect, corruption analytics, analysis of substitution times. I'm not going to say a lot here. If you want a more extensive presentation, you can find it in Bodosaki Lectures on Demand blog. This is unfortunately in Greek, but it's much longer, and there are a lot of fun facts there that make the lecture a little bit more amusing. So let's go to prediction. If we go to prediction, there are two main fields. The first one is the offline prediction, which is more traditional, and it is the prediction with the data that we have before the beginning of the game. The second is the more trendy nowadays because of the many data that we have, and this is the inline prediction, which is within the game during the course of the game. Let's see a little bit more about offline prediction, that there is more work there. So in offline prediction, we can have two approaches. The easier one is the second, to model the final outcome of the game in the form of win, draw, and loss. And then you can use multinomial regression model or a Bradley-Terry model. The first approach is more challenging, and it models directly the game scores. And this is, of course, more accurate. It allows to make more difficult predictions and more complicated bets. And this approach is based on the Poisson models and their extensions. And there is another approach that we have introduced using the difference of the goals and the scalar distribution. Again, you will excuse me because there are new techniques nowadays. There are more and more. There is more and more work appearing in the field, and therefore I will have to limit myself in the basics, in the basic publications of the field. So the simple Poisson model, it started back in 1982 by Maher. There is another publication in 1992 by Lee, with the title "Is Manchester United Really the Best?" And there is also an improvement by Dixon and Coles in 1997, one of the nominal publication of the seminal publications on the field. We had also our first try here with Professor Carly when we were students using the simple Poisson model. The simple Poisson model is also called double Poisson model. The second attempt is the bivariate Poisson model by Ioannis Ntzoufras 2003. There is also some implementation of the negative binomial. You can have a look in my book for how to implement this distribution for football data. With Professor Ioannis, we introduced also the scalar model for the difference, and we have the Poisson log normal random effects, which the log normal effects, you can see an example of this model in my book again, but the Poisson log normal random effects does not seem to fit very well to football data. The good thing with such model is that it allows us not only to predict a single game outcome, but also we can produce simulation-based results, and we can reproduce the final league. We can generate leagues, one at every iteration. And then we can, by this way, we can have a sample, a realization of the leagues. And by this way, we can estimate very complicated probabilities, like the probability of winning a league, the probability of winning some European tickets, or the probability to relegate. We can estimate the final rankings with probabilities, of course. We can estimate the results under different scenarios and assumptions, especially if we have complicated covariates. We can change the covariates and we can make prediction to see what the scores would have been, or what the final league ranking would have been if we didn't have some components in our team. The basic vanilla model of the double Poisson approach is very simple, and this vanilla model have been used in several sports also. And the vanilla model is mainly the home effect, which is well established in the field of sports and football. And we have some parameters that estimate the attacking ability of the team, and some parameters that they estimate the defensive parameters, the defensive ability of the team. Models with time evolved team parameters, with parameters, abilities of attack and the defense changing over time, they are very popular. They're quite standard nowadays. And empirical results say that time and form really matters. Some other covariates that we may use, and they have been reported in the literature, is the odds from betting teams. They are easily accessible. They are good covariates, and usually betting teams, they have access to more data than we have as outsiders. The team performance in game or before the game, the information about events and formation, team strategy, the final formation, injuries, some econo-demographic variables, and these are like stability, tradition, budget, player value, coach value, country of origin for European leagues. And these are very, very important, especially for international games between national teams, or in Champions League, for example, or Europa League. Some prior information can be used either as covariates or as actual prior information in the Bayesian framework. And the team form, usually they record the performance over the last games in a form of points. So this is the vanilla model. You can see Yij is the number of goals in the I game, and J refers if it is equal to 1 to the home team, if it's equal to 2 to the away team. And here you can see the linear predictor. For the home team is a constant term, plus the home effect, plus the ability of the home team, plus the defensive ability of the away team. Actually here, it should be minus, but it doesn't matter in terms of modeling, because if you put the classic plus here, then the defensive abilities will go at the opposite way, and good teams will have lower values, and bad teams will have higher values. And here you have the away team without the home effect, and also the attacking ability now will be of the away team, and the defensive ability will be of the home team. In a full balanced round-robin leagues where everybody plays each other the home field of each team, the parameters can be easily calculated by considering the average, by considering the averages of scores of scored and conceded goals for each team. So you don't even need modeling because it is very easy to calculate these parameters. So let's before we continue, let's say how we are going to put the data in our software. So the first is the number of observations. Here, the main response is the number of goals scored by its team. So for every team, we need to have 2 rows of data. The first row will refer to the to the goals scored by the home team, and the second row will refer to the goals scored by the second team. And we need also some dummies for every team, and a home indicator, which will say that the first team is the home team and the second the away team, and of course possibly a variable indicating in which game we are. Also, the chronological order of the week of the league is might also play a role, especially if you want to use a dynamic time-based model. And the response, as I said, the response is the goal scored by its team. Like in regression, here we do some very important assumptions. And these assumptions should be checked about if they are reasonable or not. And these assumptions will also tell us if we need from the simple Poisson vanilla model to go to a more complicated model structure. Of course, these assumptions are based on the sport itself rather than the model, the modeling approach like in regression. So the first very important assumption is whether we have dependence or independence of goals in a game. In practice, we have observed mild correlation between the two teams, but this dependence is important, especially for betting reasons. And another thing, there is we suspect that the correlation between the goals can be divided in 2 groups, 2 latent groups. The first group is when we have teams of similar strength, and then the correlation we expect to be positive. If one team scores, the other will press in order to score also. And the second group is the group where we have 2 teams where the abilities of the team, the skills are far away. A team which is much better than the other one, and what we suspect is that the correlation between these 2 teams will be negative. So here, this is a very nice scenario that people have to check in practice with data and possibly with an extensive model, because here in the bivariate Poisson setup, the correlation is the assumed correlation is only positive. The second is that the time-dependent attacking and defending parameters. So do the parameters, the skills of the team, the ability of the team change across the time? And empirical evidence has shown that, especially in football, the dynamic component is very important. That's why a lot of people, they start as a standard model from the dynamic model. So this is a second assumption that people will have to check. The third is if we need the draw inflation. In the literature, we have seen that almost in all leagues we have seen that the bivariate Poisson models, they underestimate the draws. So we need to add a component which will adjust for the draws and estimate. This is especially for draws of 1-1 and 0-0, nil. The only league that seems to have the opposite effect, that needs the inflation, is the Premier League, where the draws are lower than the ones expected. So this is another thing that we need to check. And finally, what about over dispersion? Again, we have noticed that there is a slight over dispersion in most leagues, and therefore a Poisson extension model that it will account for this, it will make sense. The negative binomial seems to behave very well, while the usual log normal random effects seem not to do very good job with such data. Finally, a question that we need to wonder before that is, shall we focus on modeling the actual scores or the outcomes? The latter are easier to model, of course, because the models are quite standard. And sometimes they might give a bit more accurate prediction in terms of win, draw, and loss. But the scores, they have more information. So in terms of uncertainty, they give us much better outcomes. And also we can do much more complicated simulations and estimate much more complicated predictions using the models that have as a response the scores. So how to check our predictions? Of course, we should do both in sample and out of sample check and diagnostics. And this the first one, the in sample diagnostics, will focus mainly on how good is the reproduction of the league. So if the league that we reproduce and the league that we have in practice, they are matching, then we can infer that overall the model fits well the data. And for the out of sample measures, we can perform a week ahead prediction. This is one standard, but over the last publications, the main focus is given in the mid-season prediction. What happens when we have the data of the half of the season, and usually prediction using the half of the season is very, very accurate. And the second is, especially when we have playoffs, then to take the data of the normal season and estimate what happens in the knockout phase. What happens with the prediction within game? Prediction within game is very difficult. There are some trials until now. The first one is based on survival analysis models, and there are some publications on the field. Most of them are focusing on the first goal, which is easier. And currently, our team is working on the problem. The second is to model the probability of event in short intervals, every 1 or 5 minutes. We can use binomial mixed models. There is a very nice approach, by Narayanan, Cosmidis, and De La Portas. I have seen this presentation twice, and it is very interesting. More interesting and challenging than prediction is the player evaluation. So the aim here is to estimate the contribution of players in each team. With this approach, you can rank and you can identify the best players and reward them. You can implement scouting, automatic scouting, by identifying early talents, and you can estimate the future performance and the value of the player, and also help manager to decide what is the best formation for a game. The methods, they start from very simple approach with binary indicators. They are often called plus-minus metrics. There are models with random effects. There is analysis of based on game performance indicators, which is somehow an adjusted or advanced plus-minus technique. We have the expected goals and the expected assists that also help us evaluate the best players in terms of these quantities. And finally, we have some models that focus on the economic or the market value of the players, and also on the transfers that they manage to get. So let's start with a simple method. The first simple approach is the one with the indicators. We built a very large model with indicators showing whether some players was on the field or not, and what was the final outcome of a game. And this is difficult to build a large data set because each game should be split in multiple lines. Not only that, you have many covariates. So actually here, as we will see in the next slides, we need to implement some kind of lasso to be able to estimate the model. The second is it's a more advanced technique on the first. It is some analysis based on the game performance of the indicators. So we introduce some measurements taken from the game, and we can estimate this, and we can use also player indicators, and we can use also these combinations to build some indices for the players. One indicative publication on the field is the one by McHale, Scarf, and Folker in 2012. But there are two more here that I like. The first one is again from the group of McHale, the plus-minus player rating for soccer, and the second one is by Fatum, is a review. So it is very interesting to see all the methods collected together. As I already said, the Lasso regression is very important. Is one of the main tools due to the large number of features that we need to incorporate the model. If you are more interested, this Professor Fatum from Norway, if I remember correctly, he has this very nice channel in YouTube, and you can go every 2 or 3 months. He publishes interesting videos about the ranking of the players and how you can estimate these metrics. Other approaches are ones based on random effects, again by the group of McHale. He has done it for the goal scores and the passing skills, and we can use also some socio-economic and marketing values in order to do that. Again, Fatum here has its contribution. So the main contributors in this area is the group of Ian McHale and Professor Fatum from Norway. Expected goals and expected assist is a very simple metric, and the media love it actually, and it tries to estimate what would have been the expected score according to the phases, to the chances within the game. And usually they build simple regression, logistic regression models where they account for how close is the shot, in what angle, and what are the skills of the players, in order to calculate these expected goals. So you can rank the players and their contribution according to these metrics, and which is very popular and easy to understand, to be understood by the media. And here it is an indicative plot showing the correlation between the actual goals and the expected goals. You can see most of the times they go together. They are highly correlated. There are some surprises occasionally, which is inside the character of the game. Here I'm going to show one small implementation by one student of mine, Anastasios Murtopoulos. He considered 351 players from La Liga, about 1,000 goals, and 110 were scored by Real Madrid. So he focused on the evaluation of the players of Real Madrid. And here you can see the attacking abilities of the players of Real Madrid that year. And you can clearly see here that Cristiano Ronaldo was much better than all the rest of the players. The value of 0 is the value that you have players of average abilities. Players lower than the average, they are worse than the average of the team. So Cristiano is really making the difference here. These are the defensive abilities, and here the defensive abilities are of the other direction. So better players are going to the opposite direction, and also Cristiano here has very good ability. Also, Jesse Rodriguez is quite good in terms of defense, but quite uncertain because he played in very few games. So here is the one result that the team of Real Madrid plays much better in terms of defense when Cristiano Ronaldo is in the field. Here we can see the defenders. The dark green is the first 11. This kind of green are the substitutes. Here you can see the attacking, and here the defensive abilities. You can see, for example, Danilo was very good in both dimensions. Marcelo better in defense. Varane also better in defense. we have these two players that they went really well in terms of defensive abilities. Pepe was very good in terms of attack, but not so good as expected, actually quite bad in terms of defense. And also this player did not perform very well in the few games that he entered the game. Similar is this picture about the midfielder. Toni Kroos is quite a good contributor. Rodriguez quite good in terms of attack, not so good in terms of defense. And Luka Modric very good in his attacking skills. In terms of attack, we have Cristiano Ronaldo, who is making a difference. Benzema also in both dimensions. Gareth Bale here seems to be problematic, especially in his defensive skills. In terms of attacking, is quite close to the average of the team. And we have these two players that they were much better than Christian Bale. And the final conclusions here is that Cristiano Ronaldo was a key player as we expected for the team. Toni Kroos' impact was higher than we may have presumed before seeing the data. Nacho Fernandez improved since the previous season, very high defensive contribution. Lucas Vazquez was a very promising player, contributed positively both in attack and defensive dimensions with low salary. Gareth Bale was a disappointment, and he performed much less than expected, and was really overpriced. And Pepe, very low defensive contributions and high salary, maybe overpriced, but maybe this is because of the style of the team and the style of the player, because his attacking ability was very, very good. Another field that unfortunately we do not have access is the metrics for physical improvement and training. These are data that focus on the training of the team and all the machinery now that the athletes they have. They collect a lot of data which can help us to improve the physical condition of the athletes. We can focus on specific skills and measure them and improve them. We can avoid injuries, which is a major issue for football teams, and improves the teams by optimizing allocated training time and resources to specific players. As we have said, if we don't work with a team, we do not have access to such kind of data, and possibly teams, they believe that these data are confidential, especially for the opponent teams. Another thing that it is quite interesting and difficult nowadays is how to model inline game metrics, which come from wearables. And the aim here is to measure the movement of players in the game, the speed and coverage, the physical condition, physical tactics, and performance. And it helps, or it should help in the future, to evaluate the performance of players and teams within game, and the manager to decide on the spot about the formation and possible substitutions or the game strategy. Another very, very nice topic, but it goes more on the operational research side. It's the scheduling of the leagues, and the aim is to construct fair scheduling, to eliminate any bias due to the sequence of games, to strengthen the competitiveness between the teams. And this is related with the next slides that we are going to see, to incorporate constraints like what happens in other sports. If we have safety issues, also maybe we don't want the police, maybe the police doesn't want to have two teams playing on the same time in the same town. Other events like concerts, if there is a concert, we wouldn't like to have it in the same day with a major football event, and the requirements of the TV rights. For example, usually in Greece, we have one game on Saturday, one game on Sunday night, and one game on Monday. So we can account for all this in a big optimization problem. And how we do that, we use operational research and optimization methods, of course. And because the problems are quite difficult, complicated, and large, we solve it with hybrid search methods. And then we validate using simulation. We can validate the efficiency of the methods using simulation methods from statistical models. This topic is also very nice and prevalent within the sports economics field, is the notion of competitive balance. And we have done a lot of work here with my collaborator, Vasilis Manassis. So what is the notion of competitive balance? The notion of competitive balance refers to the logic that when we have a balanced league, with the sense that the teams are have similar strength and they can compete each other, and the result is not certain. There is uncertainty about the result. This will increase the interest of the fans, and it will improve the athletic product. More people they will go to the field. More people they are going to watch the game from the television. So we are going to have increased profits, and this is called the uncertainty of outcome hypothesis. The notion of a balanced league is not yet well defined. Do we mean that we assume that all teams are of equal strength, or do we mean that some teams should be able to compete each other? A potential good number of teams should be able to compete each other for the champion, for the title of the champion. Usually nowadays we seem to go to this second approach, and we are interested that the teams that it will compete each other to be the teams with the highest number of fans, and this of course will create increased profits. As I said, this is a joint work with Vasilis Manassis. We have a lot of articles with him, and recently we are working with Professor Karlis on the topic on the statistical properties of some of these measures. And there is a very nice presentation at the seminar of the University of Reading, which is called Roses, on the topic. So if you are interested more, you can have a look there. So what leagues do we really want to see? All fans like the fact that the weaker teams occasionally win the game, or even a league like the Greece in Euro 2004 or the Leicester in the English Premier League. But every fan personally does not like to have their team losing. What they prefer, or they would like to have games full of excitement, very close between the two teams, and finally the winner to be their own team. And they are willing to pay a lot of money, especially for games between top-ranked teams and expensive teams, like the teams competing in a final of a Champions League, like Bayern Barcelona, if even their team is not participating in this game. So this is a nice plot we have for one of the competitive balance indicators, and this measures how much competitiveness we have for the champions in every league. And here you can see the cyan line. It refers to the index of Greece. And you can see when the index is at 1, then you do not have any competitiveness. The same team wins all the time the title of the champions. When we have lower values, then the competitiveness is higher. And here you can see that the only period that it was interesting for the Greek football is in the 80s, where we had many teams winning the league. Even PAOK and Larissa won this league at that period. After that, we have the domination of Olympiacos, and the league went up to the value of 1. This second liner, it refers to the English Premier League. The English Premier League was well known for the competitiveness between the teams. And you can see here at the early 60s that the line is quite low, which indicates that many different teams, they won the league, and there were differences from year to year. After a while, this index went back to 1. So here is one very important time point. Ferguson hired from the Manchester United, and after 6 years, Manchester United haven't managed to win anything in the league, only 2 second positions. If this was in Greece, probably Ferguson would have been fired in the first season. And this is another very important point for Manchester United. United wins the title, and exactly before this year, United got a very important transfer, Eric Cantona from Leeds, And this really made the difference for their team. After that, we have Manchester United to be dominating the league, and that's why the index is at the top. And this data, as you can see, they stopped in 2008, so that's why we have this picture. In England, we have at least 3 cases where the promoted team won the championship, and this was with Ipswich in 1961, Nottingham in 1997, and Leicester in 2015-16. And this is quite an indicative number of the mobility that there is in this league. This is the famous circle of competitiveness, and this was published on the media, on the newspapers of the UK, and this refers to the Premier League, to the season where Leicester won, and this is after 13 games. Everybody has won at least one team, and the circle closed, and so potentially everybody could have won everybody here. There are similar also circles the previous years, and also the Premier League has promoted there with the motto where anyone can beat anyone. So the notion of competitive balance is quite quite important, and even leagues can use them to promote their product. But let's see what happened after 2008. For many years I had this plot, but now I have the updated plot thanks to my collaborator. Before that, let's see first what happens in Germany, which is a peculiar case. We have here the red line, and you can see periods where we have high competitiveness. And you can see here for the first period in the 60s, in the 70s, that we have many teams winning the title. After that, we have a period going to one, and this is because we have Bayern dominating the league. And after a while, we have again the Bayern not winning the league. We have other teams. So Bayern seems to have some periods of high season. Again, the same here. Bayern dominates. Here, other teams. And here we have again Bayern going to one, and then again going down. So here we have ups and downs, and it seems that Bayern dominates the league for some seasons, and then it rests a little bit. Possibly players are retired, and they have new players, young players. They leave other teams to win, and then they return back to the top. So this is the final season, the final 3 seasons according to the plot. So here we have only one case that the promoted team like Kaiserslautern won the championship. And let's have a look now what happened after 2008. You can see here that Olympiacos dominated the league, but we have here the Panathinaikos, that Panathinaikos won, and also Olympiacos was ranked 5th here, and this created a little bit decrease on the index. And again, here we have a decrease on the index because AEK won the title. Similarly, here we have after 2008, and this is the one nominal. And here, at this point, we have the retirement of Ferguson. Let me show this again. Here it is. And after that, we have the index going back to the levels of the 60s, and we have even Leicester winning the title. And this makes, again, the championship highly competitive in the Premiership. The opposite effect, we have it in Germany, where Bayern dominated the last leagues, and the index went back to 1, as we have seen until now, with the behavior of the German Bundesliga. Some concluding remarks. Prediction is very important for the fans in terms of betting. It increases profits of bet companies and the interest for the sport product itself in a macro perspective. Inline prediction is also very important for fans in terms of betting. It increases profits of bad companies and interest for the sport product, but now through the media and the TV and the radio and the internet during the game. This is what I mean here. And the player performance evaluation is interesting for everybody, the fans, because they like doing rankings and player comparisons, the teams, because they would like to have an efficient scouting to calculate the future performance and value of players, for companies in order to see which players to sponsor, players because they earn a lot of money from all the previous activities, and coaches and manager because they would like to select the best players for their teams. What about physical measurements and trainings and games? It is related with game evaluation, main value to help manager to improve their teams. In the macro perspective, also the team's financial position will be improved. What about scheduling and competitive balance? With these two topics, more fair and balanced context, which can be produced, which lead to better products, overall product, and more profit to all teams. So this is the end of the talk. I would like to thank you for being here with me.